Howdy folks. Here's what we're going to do in this video is I'm going to explain what's called polynomial long division, or just polynomial division. It is a kind of division where instead of dividing numbers, you are dividing algebraic expressions. Okay, so let's say, well, let me write this up here, polynomial division. Now, let's say that we have some kind of fraction. Let's say the fraction is x to the fourth power minus 9x to the third power plus, let's say, 2x squared plus 5x minus 3. All right, just making stuff up here. And it's over, this is a fraction, so it's over x squared plus, let's say, x squared plus 4, okay? So this is a fraction. It's a rational expression. But remember, with fractions, like if we have, 10 over 5, it's also a division problem, right? So we could divide 10 divided by 5, and 10 divided by 5 is 2, and so 10 over 5 is the same thing as 2. Similarly, if we had 7 over 3, this would become 2 and 1/3, correct? Okay, and we could write this, just so we understand, we could write this as 2 plus 1/3, right? And the reason that this happens is because 3 only goes into 7 2 complete times, and then there's 1 left over, because 3 times 2 is 6, and when 6 out of 7 leaves 1 left over, right? So what we do is we just sort of tack on this plus 1/3 where 1 is being divided by 3, okay? So you got to remember that. That's an important concept for this polynomial long division. So we could take this and turn it into a division problem, okay, where we, remember old school division where you kind of draw this thing over the dividend, and then we'll put the divisor, or x squared plus 4, on the outside, and now it's not a fraction anymore, but it is still this thing divided by this thing, right? So here's what you do. It's very important to understand. This plus 4 it's going to be used, but this plus 4 is not, it's not a main portion of the division. Mainly what you're doing is you're only ever using the largest, what we call the lead term, the term that has the highest power. That's what it is that we're going to use to be dividing into the rest of this, okay? Now, when you divide, if you recall long division, like if we were dividing 7 into 463, what we typically do is we try to see how many times this number goes into the first number, and if it doesn't go into the first number at all, then instead of it being 4, then we turn it into the first 2 numbers, 46. So 7 goes into 46 6 times. Then we multiply the number up here times the number over here. 6 times 7 is 42. Then we subtract, right? And then 46 minus 42 is 4. Then we bring down the next number, and it becomes 43. And then we do the same thing again. 7 goes into 43 another 6 times. 6 times 7 is 42. And then there, if we subtract again, there's 1 left over. And so we say remainder of 1, right? But really what this remainder of 1 means is 1/7. So this would be 66 and 1/7. Okay? That's what 463 divided by 7 would equal. So now, with that review, let's go ahead and do polynomial long division. What we're going to do is we're going to take just the x squared. We're going to ignore the plus 4 for now. We're going to divide the x squared into the first term in this polynomial. So if we were to do x to the fourth divided by x squared, what would we have? Well, x to the fourth divided by x squared is equal to 4 minus 2. Remember, when you're dividing polynomials or terms of a common base, you subtract the exponents. 4 minus 2 is 2, so this would equal x squared. And so we're going to put an x squared up here. That's the beginning of our answer. Then what we're going to do is we are going to multiply, then subtract. We're going to multiply this times the whole thing. X squared times x squared is x to the fourth power. Then x squared times 4 is 4x squared. But here's the thing. We're not going to put it right here. We have to put it under a term that is a like term, because we can't subtract terms that are not like terms. So we're going to take the x squared times the 4, that's 4x squared, and we're going to put it underneath the 2x squared, so 4x squared. And basically what we're going to do now is subtract. We're going to draw this line, and then we're going to subtract this from this, and we're going to subtract this from this. Okay? So x to the fourth minus x to the fourth, well, that cancels. So it's 0. Then we're going to do 2x squared minus 4x squared, and 2x squared minus 4x squared is negative 2x squared. And you know how whenever you have something left after the multiplication, you then carry stuff down, right? Well, what we're now going to do is we're going to carry down the things that we didn't use. And we did not use negative 9x cubed, and we did not use plus 5x, and we did not use minus 3. And then what we're going to do is we're going to do the same thing again. Now, we're going to take the x squared, and we're going to divide it into negative 9x cubed. Another way to think about it is negative 9x cubed divided by x squared. So, there's a 1 in front of the x squared. Negative 9 divided by 1 is negative 9, right? Then x cubed divided by x squared, okay, well, 3 minus 2 is 1, so that's x to the first power, or just x. So if we divide negative 9x cubed by x squared, we get negative 9x. And so we're going to put that up here. Negative 9x. Now you could put these over their respective powers. It doesn't really matter that much, at least not to me, it doesn't. But if you did, this x squared would go over here, and this negative 9x would go over here. But this is the highest power that you're going to have anyway, so it's not really going to matter. All right, so we got our negative 9x. Okay, and now we're up here. And so what do we do with the negative 9x? Well, we multiply it by x squared plus 4. Well, what is negative 9x times x squared plus 4? This is just another way to do it. You could do it off to the side. Well, if we were to distribute the negative 9x, we would get negative 9x times x squared is negative 9x to the third, and negative 9x times 4 is negative 36x, right? All right, well, remember that when I do it this other way. Negative 9x squared, or excuse me, negative 9x times x squared is negative 9x to the third. And then negative 9x times 4 is negative 36x. I'm going to line that under here, or line that up under here. Negative 36x. Okay? And so look, it's the same thing as what we got before. Negative 9x cubed minus 36x. Okay? All right. Now we're going to subtract. Here's what I mean by that. We're going to subtract this. Even though it already has a negative sign on it, we have to subtract it. So we're going to subtract negative 9x. Same thing here. We're going to subtract this from this. Well, what is negative 9x cubed minus negative 9x cubed? Negative 9x cubed minus negative 9x cubed. Well, this negative and negative becomes a positive, right? So that's almost like saying negative 9x cubed plus 9x cubed. Well, those cancel, right? So that's gone. Let me draw this line. And then here, it's going to be 5x minus negative 36x. Well, minus negative, again, means plus, right? So it's like 5x plus 36x, which would be 41x. Now we're going to carry down everything that we didn't use. We're going to carry this down. Negative 2x squared. This is a positive 41, so we'll put a plus. Bring down the minus 3. And now we're going to continue. Will this x squared divide into this first term here? It sure will, and because it'll divide in, we can go ahead and divide it. So x squared, if we were to do negative 2x squared divided by x squared, right, we would get negative 2. See, because these x squares would cancel. So x squared into negative 2x squared is negative 2, so I'm going to put that up here, negative 2. And as you can see, this is turning into a polynomial expression. That's what our answer is going to be right there. So now we take this and we multiply it by this. Negative 2 times x squared is negative 2x squared. Negative 2 times 4 is negative 8, and I'm going to put that under the negative 3 here. Now we're going to draw our line, and we're going to subtract each of these from what's above them. Negative 2x squared minus negative 2x squared is 0. They cancel each other out. Do you notice that in every one of these cases, the first term cancels out? That's just the normal part of the procedure. That will always happen. That first term, if you do it right, should always cancel out. Now, what is negative 3 minus negative 8? Well, that's like the same thing as negative 3 plus 8, and that's positive 5, right? And then just carry down the 41x. Now here's what I want to point out. You can't divide x squared into 41x and get something that you can put up here, because there aren't any x squares in here. It'll cancel this x, and the divisor will still have a portion of it remaining. So here's what we do. So this is the remainder. This is the remainder. All right? This is the remainder. And our answer, our final answer, will be what you see up here. X squared minus 9x minus 2. And then this is positive 41x plus 5. So because it's positive, we're going to put plus. And now it's going to become a fraction. 41x plus 5 over x squared plus 4. And that's our final answer. That's how we divide polynomials. I think we should do one more example just so that you can get a feel for this. So I'm going to erase this. Okay. Polynomial division. It's good stuff. All right. So let's try, let's divide x to the third power minus 2x plus 1. Let's divide that into, we're just going to divide it into something simple, x to the fifth plus 10, let's say. Okay, now you might think, oh, that looks kind of small. That's only 2 terms, and that's 3 terms. Yeah, but we can still do this. The procedure still basically works. So here we go. So we're going to divide. We only care about this x cubed dividing into things. Okay, so here's what we're going to do. We're going to go x cubed goes into x to the fifth how many times? Okay, well, x to the fifth divided by x cubed. And if you want to pause this as we go and try these on your own, you can pause right now and try this first step and then start it up again. X to the fifth divided by x to the third is x squared. So we're going to put an x squared up here. All right. Now, x squared times x to the third is x to the fifth power, right? Now, we're going to do x squared times negative 2x. Well, that's negative 2x to the third power, right? And then we have x squared times 1, which is just positive x squared, okay? And you say, well, wow, well, we didn't have these powers inside of here. Well, that's okay. It's okay to do that. Watch what I'm going to do. I'm going to sort of move this 10 over. I'm going to move this 10 over way over here, okay? So we've got x to the fifth plus 10, because these powers, they still exist, but they're zeros. It's almost like we have, you know, plus 0x to the third plus 0x squared plus 0x. They're in there, but 0 times x to the third is 0. and 0 times x squared is 0, and 0 times x is 0, and why would we put a whole bunch of zeros in there? We don't put zeros in. We don't put plus 0 when there's a plus 0 in there. So that's why you can't see them. All right, so now what we're going to do is we're going to subtract. So we're going to subtract x to the 5th from x to the 5th. Then watch this. We're going to subtract negative 2x cubed from 0, because remember what I said, there's a 0 up here. We're also going to subtract x squared from a 0. So x to the 5th minus x to the 5th, that cancels. 0 minus negative 2x cubed, well, minus negative, that's plus. So that's 0 plus 2x cubed gives us 2x cubed. And then here we have 0 minus x squared, and that's negative x squared. Now we're just going to carry down the plus 10. Okay? All right, that's our first step. Now we're going to move on to the next division. We're going to take this, x cubed, and divide it into 2x cubed. Well, how many times does x cubed go into 2x cubed? Okay, well, 2x cubed divided by x cubed, well, these cancel and leave us with 2. So it's positive 2. So x cubed goes into 2x cubed positive 2 times. And typically, here's just a hint. When you get to the point where you're putting a constant up here with no x's, that's pretty much going to be your last row, or your last iteration. So now we're going to multiply 2 times all of this. 2 times x cubed is 2x cubed. 2 times negative 2x is negative 4x, and 2 times 1 is 2. And now we are going to subtract. Subtract. 2x cubed minus 2x cubed, well, that cancels. Now watch this. We have negative x squared minus nothing. There isn't another x squared, so we're just going to carry down the negative x squared. Then we don't have an x to the first power term up here, right? So it's a 0. So 0 minus negative 4x. Minus negative is plus. 0 plus 4x is plus 4x. And then we have 10 minus 2 is 8. So plus 8. And so now this is an x squared. This is an x cubed. So we cannot divide this into this. So that makes this our remainder. And so our answer is going to be whatever's up here, right? Our answer is going to be x squared plus 2. And then we have this thing here, right? It's negative x squared, so we're going to put a minus, and then we'll put x squared. Oh, sorry, no, I can't do that. I got to factor out. Okay, there's 2 ways to do this. See how this is a negative? If you want to put the minus here and then put this up here, you're going to have to reverse all the signs. X squared minus 4x minus 8. And here's why. Because this negative is being distributed. This is negative 1 times x squared, negative 1 times negative 4x, negative 1 times negative 8, which would give us negative x squared plus 4x plus 8. Okay? So you can do that, or you can leave the signs and make this a plus every single time. All right? But we're going to put it over x cubed minus 2x plus 1, and that is our quotient. That is how we divide. That's how we divide polynomial expressions. Okay? I recommend that you, if you still have questions about this, well, you can come see me, of course. But also, there are a lot of resources online. This video in YouTube is probably sitting right below another video that might be on polynomial long division, or maybe below, maybe right down there. Is there another video down there somewhere that's on polynomial long division? Because there's tons of videos out there on polynomial long division. You can also just Google polynomial long division practice or worksheets, and you will find tons of stuff on the internet on polynomial long division. But here's the truth. You will only really understand this and know how to do it if you do it. Staring at it and saying, I don't know how to do this, it looks really hard, that's not going to get you anywhere. You look at it, you say, hey, it looks a little difficult. Let me jump right in, because that's how people accomplish difficult things. They acknowledge the fact that it looks difficult, and then they say, I'm going to go for it. And then they do everything that they can to get it done. So there you go. All right. Have a great day.